So, getting out of the R chapter into complex numbers in section 1.3. Complex numbers. Complex numbers are defined by this little set, and I'm going to put star by it because it's an important thing. We got the square root of -1. That's where the complex numbers comes into play. Square root of -1 is defined to be I. It represents the letter I. It's not a variable. That's what it represents. Okay. But we're going to treat it like a variable when we start working with complex numbers. Okay. So square root of -1 is I. One of the things that we'll need, some of the things we'll need for this are if you square I, you're going to get -1. I squared is equal to -1. I to the third power is -I. Those are things we will need to know. And then I to the fourth power is +1. That little table is important when we're talking about working with complex numbers. Okay, a complex number looks like this. This is the real part. This part is the imaginary part. That's how they break it down. You have an imaginary part, a real part. The complex number means you're putting imaginaries and reals together. That's what makes it. That's what defines the complex number system, is we're putting them together. Real part goes first, complex or imaginary part goes second. That's how we're going to write our complex numbers when we write answers out of this. Now, complex numbers, when we're dealing with the imaginary part of those come from square roots. Okay, so what we're going to do is we're going to simplify some square roots again. This ties right together with the other lesson. Example A, let's say we had the square root of -24. Very similar to what we had before. The only difference is that it's got a negative number in there. Okay, so if we're going to simplify the square root of -24, I'm going to break down the 24 with the factor tree just like before. So I'm going to take that and I'm going to say, okay, well, it's 24. That's 12 and 2. And then 12 with 6 and 2. And 3 and 2. So I look at that and I say, okay, I got a pair of 2s. And then I got a 3 and a 2 left over. But the negative on the inside means an I comes out. Anytime there's a negative in the square root, you can always pull I out of the radical. Okay? And then 6 will be left on the inside because it's 3 times 2. That's the 6. 3 times 2 is 6. So 2I radical 6 is the simplified version of the square root of -24. What about the square root of -35? If we're dealing with the square root of a -35, I'm going to try to break down 35. Well, it's 5 and 7. Those are both prime numbers. There's no pairs. So that means no number comes out. But because it's -35, I comes out. And you're left with I radical 35. Just because there's a negative under there, you could pull an I out. And it simplifies just a tad. And that helps us get on the way to complex numbers or imaginary numbers in this case. If you're multiplying them, then you want to actually simplify first, is what you want to do with negatives in there. Like we have the square root of -7 times the square root of 14. You don't want to multiply that together first because the negatives on the inside create a problem. Okay. So what you want to do is say, okay, well, that's I radical 7 times I radical 14. That's what you want to do for a first step when you're multiplying. If there's a negative inside of the radical, there's no negatives in the radical, then don't worry about that. You just multiply. Okay. So we're going to multiply these together now. So I times I is I squared. And then 7 times 14. That'd be 70 plus 28. That'd be 98. And then I'm going to simplify that. I got that 7, 14. That's 7 and 2. So there's a pair of 7s. 7i squared radical 2. The 2 comes from that 2 that's left over. The 7 from the pair of 7s. What do I know about I squared? It equals negative 1. So I'm really going to have 7 times negative 1 square root of 2. But 7 times negative 1 is just negative 7 radical 2. Negative 7 radical 2 is what I've got there. If I had multiplied at the beginning negative 7 times negative 14, I would have got positive 98, and I would have lost the negative sign that's there. So that's why when there's negatives under the radical, you want to take care of those first and put i's out here because it messes up the sign of the answer out of that. Okay, so that's why you need to do that first on the ones that have negatives on the inside. All right, let's do one more of those. Say we had the square root of negative 8 times the square root of negative 15. So I wouldn't do a whole lot of work as far as simplifying the numbers. I would just do the I part first. I times I is going to be I squared radical 8 times 15. 120. Okay. I'm going to break down 120. 12 and 10. 6 and 2. 3 and 2. 5 and 2. I got a pair of 2s. And then a 3, 5, and a 2 left over. 5 times 2 is 10 times 3 is 30. So that's going to be 2i squared radical 30. 5 times 2 times 3 is 30. We know I squared turns into what again? Negative 1. So that's 2 times negative 1 square root of 30. And that would be negative 2 square root of 30. The final answer there. All right. So fairly simple in that regard. Let's talk about adding and subtracting them, the complex numbers. Okay. Even easier than the radicals because they're already complex numbers. So you might have a complex number like 3 plus 5i plus 6 minus 2i. So it's two complex numbers, adding them together. It's just like simplifying polynomials. You put the like terms together. That's all there is to it. 3 plus 6 is 9. 5 plus negative 2 is 3i. That's as easy as it gets, guys. It doesn't get much easier than that. Now, here's what can happen with this. If you're unsure of yourself, you've got a great resource. You got that graphing calculator. It'll do this, the adding and subtracting of complex numbers and the multiplying of complex numbers for you. To get it to do that, you put your numbers in there. You do 3 plus 5, and to get the I, you press second and then the decimal point down at the bottom. And I'm closing those parentheses, plus, and then I'm going to do 6 minus 2i. 6 minus 2, second decimal point. And there I get 9 plus 3i, just like I did without, it's easy to do without the, calculator, but, you can check yourself there. I usually don't do addition and subtraction in the calculator unless I'm just really unsure of myself and I'm really tired and I don't feel like doing it. But multiplication I do usually do in the calculator. So let's look at one of those multiplication problem. Let's say we had 2 minus 3i times 3 plus 4i. I'm going to show it by hand, and then we're going to do it with the calculator as well. So I want to make sure, I've shown you how to do it by hand. So to do it by hand, it's distributive property just like we started the day with. You're saying 3 times 2 minus 3i plus 4i times 2 minus 3i. It's just distributing this to both terms, just like we started today with. Okay? And then multiply it out. 3 times 2, 6 minus 9i. And then 4 times 2 is 8i. And then here's where it gets a little sticky. 4 times negative 3i. 4i times negative 3i squared is negative 12i squared. So this is where, you got to keep in mind, okay, I squared is really negative 1. So that's going to be 6 minus 9i plus 8i minus 12 times negative 1. And when you work that out, this becomes positive 12. So we have 6 plus 12 is 18. And then negative 9 and positive 8 is negative 1i. So there's a lot of simplifying that can happen there. That's doing it by hand. With the calculator, you just type it in just like that. You to parentheses 2 minus 3i. So second decimal point to get the I. Close the parentheses, open up another set, 3 plus 4i. And there we have that answer. So the multiplication I usually do use the calculator for, especially if it's a straight question about doing just that, multiplying two complex numbers together. It is definitely something you can do with that really easily. Okay. Another thing that comes up with the complex numbers that we try to work our way around would be if I have I in the denominator, 5 divided by I. One of the things with complex numbers is that's not written like a complex number because the i's in the denominator, and you don't want to have that. By hand, the way of doing that is multiply both sides, both top and bottom, by I, so that this ends up being 5i over I squared, which is really 5i over negative 1, which is negative 5i. And it really just changes the sign to negative, puts the I up top. The calculator does the same thing. 5 divided by I. You hit enter on that, it does that for you. It'll just crank that out. And I'm okay with you doing it with the calculator like that. That's absolutely fine with me. But the reason we do that is because that's not the form a complex number normally takes. The I shouldn't be in a denominator. It should be up with the number there. If you had 6 over 7i, that's still the same problem. The I is not in the, beside the number. So you really just multiply by that. So 6i over 7i squared. And this is the math that works to make this happen. So it would be negative 6 over 7i. with the calculator, it does the same thing. 6 over 7i. And I think actually you need to put the, let me clear that. 6 divided by parentheses 7i. That's the kicker on the calculator. You've got to do that parenthesis stuff and hit enter. And I'm going to hit math, enter again to get it back to a fraction form. And there we have the same answer. If you don't put it in parentheses, it's not going to do the correct thing, okay, in the denominator. That's what you got to be careful of. One other thing that comes up is, what if you have a complex number in the denominator, like 3 over 5 plus 2i? That requires the use, to do it by hand, it requires the use of a conjugate. And the conjugate, all that means is it's the matching pair from a difference of squares. It changes the sign in the middle. And then you do the math from there. So I'm going to do this by hand, but I really do expect you to do this with a calculator, honestly. So I'd say 3 times 5 is 15 minus 6i. And on the bottom, it'd be 25 minus 4i squared, which ends up being 15 minus 6i over 25 plus 4. So that's 15 over 29 minus 6 over 29i. That's doing it by hand. I don't expect you to do it by hand. You got a graphing calculator, it'll do this for you. If you just type it in correctly, 3 divided by, and here's the correctly part, you got to use parentheses with the 5 plus 2i. Without those parentheses, it's not going to do it correctly. And then I'm going to hit math, enter to get back into fraction form. And there's my 15 over 29 minus 6 over 29i, which is what I got there by doing it by hand. I fully expect you to do that with the calculator, not necessarily have to do it by hand at all. This particular portion doesn't come up too much in when you're working with solving quadratics, as far as having the I in the denominator. It is more like that sort of stuff where you've got to simplify a radical that comes up with the solving of quadratics, which is where we do most of our stuff. But that's one of the things in the classes you've got to look at that and see about doing simplifying a radical. But you also got to look at complex numbers not having that I in the denominator to keep things from there. So that finishes up material for today. I'm going to put up some problems here that you would probably want to look at. Let's see. Make sure I've got the right pages there for that. So page 29, I believe, is the R3 section stuff. Yeah. 29 and forward from there. 45 through 85 is where we looked, that sort of problems. 38, page 38, 1 through 45, and then 51 through 69. I would suggest looking at the odd ones there if you're going to look there. And then there's not much practice in the book on the simplifying of radicals only. You get some practice simplifying radicals when you're looking at the complex numbers on page 103. Page 103, numbers 17 through 79. Obviously, the odd ones there. I may post. I've got some handouts and things that I've saved over the years. I may post a few, one of those that will give you some extra practice on simplifying radicals only, just the square root stuff. On the announcement that I'll send out with the links to the videos of the lecture. And that way you've got something else to practice. It'll have the answer key with it so that you'll be able to check those sort of things. But that'll get you ready for that. Labs for this sections, 15, 16, and 17. I'll post videos for those this afternoon, and you'll have those available. Labs 10, 11, 12, 10 through 17. Those labs will be due on June the 27th. So labs 10 through 17 going to be due June 27th. Exam 2 is due June 27th. Exam 3 will be due June 27th. The labs 18, 20, and 21 will be due June the 27th. A lot of stuff due the 27th. We've still got class Thursday. That'll cover the material that's on exam 3. Will be what we cover on Thursday this week. We'll meet at 9. Should be out of here by lunch again on Thursday. So you can kind of count on that. It may be a little bit past that, a little bit longer problems on Thursday with this stuff because it's solving some equations and things like that. But we'll be looking at that. And remember, next week we will not meet any next week. All right. So email me if you've got questions. Something comes up, you need some help with something. Please email me. I'll be glad to. I'm trying to get back to you as soon as I can when I see your emails, and be as helpful as I can. Folks that have emailed me have done a good job of sending a picture of what you're having trouble with. That's helpful. Really helps me be able to help you quicker without having to go look up some, what problem you're talking about. So if you'll shoot a picture with what you're working on, that helps. All right. I appreciate y'all being here today, and I'll see you on Thursday. Y'all have a good rest of the day.